All right, so we're looking at knowledge check 20.6.1. For this one, we're going to use the flights data from the NYC Flights 13 package, and we'll use the non-ER package to do a little missing value analysis. All right, so question one, identify which features have missing values, and then question two is how many missing values are in each of these features. We can do this all at the same time, and we can easily do this just by saying, all right, is NA across flights. This is actually going to produce trues or false for every single element. If we wrap this with sum, we'll get the total number of missing values across all of the elements in flights. And we see we have over 46,000 missing values. Now, which columns do these actually sit in? We can find that by looking at the call sums. And actually, let's go ahead and sort these in decreasing true order. And this will show us which variables have some missing values in versus those that do not. So we can see that the missing values are focused really in arrival delay, airtime, arrival time, departure delay, and tail num. So we got 6 variables where we have missing values. All right, do there appear to be a relationship between missing values for these features? Do they tend to be missing at random, or do they tend to be missing in unison? Well, a couple ways we can look at this. First one is, let's look at viz miss. And this is provided by the non-ER package, and we could look at flights. Now, when we run this, we'll get an error, simply because this function can take a little while. And so by default, it gives you this warning if you are gonna apply this function to a very large data set. We can actually override this, and we could say warn large data, set that to false, and now we can run this. It is going to take some time, but we will get some results. All right, so we got our results. Now when we look at this, we can see that we have these darker dashes, and these represent individual observations. We actually have a lot of observations in this data set, so that's why these dashes are so thin. They look like little thin lines versus boxes. But these represent where there are missing elements. And we can see that there's this consistent pattern that when we have departure time missing, we also have departure delay, and arrival time, and arrival delay, and air time. There are a few cases where we have some other information, such as like tail num is thrown in here, but we can definitely see that there's this pattern that pretty much when departure time or departure delay are missing, that we have these other variables that are consistently missing with it. Another way we can look at this is to go ahead and use this ggmiss upset. And when we call this, we can set nsets. In this case, I'm going to set nsets to 6. Nsets basically says what are the different combinations of variables that we want to look at. And I'll do it in order of those variables that have missing values. So we have 6 variables with missing values. So if I set this to 6, it'll look at basically the combination of missingness across these 6 different variables. Now, what this tells me is that there are 5,743 observations where we have departure time, departure delay, arrival delay, and air time all missing at the same time. And then we have 2,512 observations where we have all 6 of these variables missing at the same time. So we definitely see the strong pattern that when one of the variables has missing value, that the others do as well. And so this does not seem to be missing at random. It seems like this is I don't want to say on purpose, but because of a certain reason. And likely that reason is that there's been like a permanent delay of the flight, that it basically goes from one day to the next day. And when that happens, we tend to have all missing values, because then that flight rolls over to the next day, and then that will likely get a new flight number, and then the times of actual departure and arrival times, and all that information gets collected then.